Now let's talk about databases in AWS. And first, I want to give you an introduction as to what is a database and the different types of databases we have today. So when you are storing data on disk, would it be on an EBS drive, an EBS volume, an EC2 instance store, Amazon S3, you have your limits. If you want to store data in a structured way, you may want to store it in a database. And this structure is going to allow you to build indexes and to efficiently query or search through the data. So while we have with EVFS, EBS, EC2 Instance Store, and Amazon S3, we can do per files operations. With databases, it's going to be a lot more structured. We can define relationships between your data sets. So these databases nowadays, they're all optimized for a purpose, and they will come with different features, shapes, and constraints. From an exam perspective, it's up to you to understand which database is going to fit best the use case given to you by the question. So the first kind of database that has been very common and is still very common today is called relational databases. So if you've used Excel before, you know Excel spreadsheets. This is just the same as Excel spreadsheets, but you have links between each table. So for example, we have the students table, and as we can see, we have 4 columns, and there's a student ID, a department ID, a name, and an email. And then, for example, you would have a second spreadsheet called the department spreadsheet, which takes the department ID and adds more information. And the idea is that in a relational database, you are defining a relation between the department ID, the second column in the students table, into the first column of the departments table. And you can even define more relations. For example, you can define a subjects table and link the table of the students to the subjects by defining another relation. This is why it's called a relational database. Now, in relational databases, the particularity is that you can use the SQL language to perform queries or lookups. So these, whenever you hear SQL, think relational databases. Next, we have NoSQL databases. NoSQL means non-SQL, which means non-relational databases. So NoSQL are new or more modern kind of databases. They're built for a specific purpose with a specific data model in mind, and they have a flexible schema for building modern application. A schema is basically the shape of the data. So the benefit of using a NoSQL database is that you have more flexibility. It's easier to make the data model evolve. It's scalable, so it's designed to scale out by adding distributed servers. So the example from before, the relational database, it's not easy to add servers to scale it. So you have to scale up by doing some vertical scaling, but with NoSQL databases, you can do horizontal scaling. It's also high performance. It's optimized for a specific data model. It's highly functional. The types are optimized for the data model. And finally, some examples of NoSQL databases are going to be key value databases, document, graph, in-memory, or search databases. We will be seeing those in this section. So, for example, in a NoSQL database, you can have the data in a JSON format. So JSON stands for JavaScript Object Notation, and we've seen it before. This is the same language we've been using when we defined our IAM policies, and this is what a JSON document looks like. As we can see, this does not look at all like an Excel document. So JSON is a very common way to describe data. And as we can see in here, we have different sub-nesting of the data. We have different fields, different names, different types. And so it is a very common way to model data in a NoSQL model. The data can be nested. For example, if we look at address right here, it is nested within the higher object element. So address and types are going to be nested. The fields can change over time, so it's up to us to add a new field into our JSON document. And there's support for arrays. For example, John, who is 30, has 3 different cars, Ford, BMW, and Fiat. He's a lucky man. Okay, so databases, as you can see, can have different forms, and we'll be seeing them in details in this section. So just some words around databases and the shared responsibility model on AWS. So AWS will offer to manage different databases for us. So these are the offering we'll see. And the benefits of using a managed database is that it's very quick to provision. Usually AWS will have high availability in mind when designing it. And if you want to scale your database, you can do vertical and horizontal scaling pretty easily. They will also include some utilities to do automated backup and restore of your databases, as well as operations and upgrades. And if you need to patch the operating system of the underlying instance, actually it's not your responsibility anymore. it's AWS's responsibility. So AWS will be responsible for the entire database in terms of patching. The monitoring and the alerting as well are going to be integrated. And so this is why using a managed database on AWS is very, very important and very beneficial. So you are obviously able to run your own database technology on an EC2 instance, but if you do so, you need to handle yourself all the things associated with resiliency, backup, patching, high availability, fault tolerance, and scaling. So this is why, in this case, using a managed database is going to be a lifesaver for so many of our use cases, okay? So in this section, we'll have a look at all the managed databases from AWS and which use cases they fit. So we'll see you in the next lecture. The first kind of databases we're going to see is the relational databases, and for it, we have RDS. RDS stands for Relational Database Service, so it's very clear that it's only for relational databases, and it will be using the SQL language. So it's a managed database service for databases that will use SQL as the query language, and it will allow you to create databases in the cloud that will be managed by AWS. These databases can be of different kinds. It could be a Postgres, MySQL, MariaDB, Oracle, Microsoft SQL Server, and finally, something called Aurora, which is a proprietary database from AWS, which we'll be seeing in this lecture as well. So why would we use RDS instead of deploying our own databases on EC2? Well, RDS is a managed database service, so provisioning the database will be automatic. The patching of the operating system will be done by AWS. We will have continuous backups and restore options with point-in-time restore. We'll have monitoring dashboards to see if our database is doing good. We'll be able to scale the reads by creating read replicas and improve the read performance. We will have the way to set up multi-AZ to make sure that we're ready to have a plan for disaster recovery against a whole availability zone going down. And finally, we can set up maintenance windows for upgrades, and we can scale vertically and horizontally. The storage is going to be backed by EBS, would it be a GP2 type or IO1 type volume. And the only thing that we cannot do with an RDS database is that we cannot SSH into your RDS database instance, okay? We're just using the service. AWS manage entirely the database for us, so we cannot use the SSH utility to see what's going on within our database. Okay, so where does RDS fit within our solution architecture? Well, we have our load balancer, and it's fronting multiple backend EC2 instances. They're possibly into an auto-scaling group, and they need to store and share the data somewhere. And this is structured data, so they're not going to use EBS or EFS or EC2 instance store. They will be using a database. And in this example, it is a relational database, so SQL based. And the EC2 instances will be connecting to the database and doing read writes and all at once. So they will be sharing the database in the backend. And this is a classic solution architecture, not just using RDS, but using any kind of database. You have the load balancer layer that will be taking the web request, the backend EC2 instances doing the application logic, and the last tier, which is the right-hand side, which is going to be the database tier, doing the reads and the writes of the data. Okay, so this is for RDS. So now for Aurora. So Aurora is going to be a database technology created by AWS. It's not open source, and it works the same way as RDS. We have our EC2 instances connecting directly into Amazon Aurora. And Aurora supports two kinds of database technologies. It supports PostgreSQL and MySQL. The idea with Aurora is that it's going to be cloud optimized, and so there is a 5x performance improvement over MySQL on RDS and a 3x performance improvement over using Postgres on RDS. On top of things, we don't need to worry about the storage of an Aurora database because the storage will grow automatically in increments of 10 gigabytes up to 128 terabytes. Even if Aurora is going to be more expensive than RDS, about 20% more, it's going to be more efficient, and so it should be more cost effective. Finally, Aurora is not something that's included into the free tier of AWS, but RDS is, okay? So from an exam perspective, RDS and Aurora are going to be the two ways for you to create relational databases on AWS. They're both managed, and Aurora is going to be more cloud native, whereas RDS is going to be running the technologies you know directly as a managed service. Now we'll see you in the next lecture just to give it a go and try to create our first database. So let's go ahead and create our first database in RDS. And we're not going to go over all the options, okay, but we're going to see the general idea of RDS and how it works. So on the left-hand side, I will go under databases and I will create a database. So here we have the interface. And so we have a standard create and an easy create. So an easy create is to use recommended best practice configurations, okay? Whereas the standard create allows you to just customize everything. So for the purpose of this demonstration, I will use a standard create. So we have different options of the engine. We have Aurora, MySQL, MariaDB, Postgres, Oracle, and Microsoft SQL Server. So in this demo, we're going to launch a very simple managed MySQL database using RDS, but we can see that there's a lot of options available to us. We'll use the MySQL community, and then we'll use the latest version, what that is recommended, 8.0.23, but it really doesn't matter. Here we have some templates to launch our MySQL RDS database. We have the production templates, the dev test template, or the free tier template, which is quite nice because it pre-fills some of the settings from below. And we'll see what they mean. So if we go into the free tier, because we want to stay within the free tier, let's scroll down. For the DB identifier, I will use database 1. This is fine. Here, there's a master username. So admin is great. And then the password, I will enter password twice. And then I will scroll down. The database class is now a burstable class of T2 macro. Well, that's the only one I can actually enter here because I went with the free tier setting. But if I went with, for example, production setting, I could be choosing another type of class, for example, any kind of class in here. But again, we'll stay within the free tier and use a T2 macro type of database. I'll scroll down. We have some settings around storage. We can enable 20 gigabytes of GP2 SSD storage, and then we can have storage autoscaling in case we are having more storage than 20 gigabytes. It will automatically increase the storage for us with a maximum of 1 terabyte, 1000 gigabytes in here. Availability and durability, for now, we will not go over these settings. Connectivity, so where do we want to launch the database? So we specify a virtual private cloud or VPC, as well as a subnet group. Do we want to have public access to our database, yes or no? Well, you need to specify yes if you want to be able to connect to your database from your computer if you don't have direct connectivity into AWS, which should be the case for you. So we'll keep it as yes, public access. Then we should assign some security group. So you can create a new security group. I'll call it demo database, RDS. And the AZ is going to be no preference. This is fine. And the database port is 3306. Excellent. Now, how do we want to authenticate to the database? Using password or password in IAM or password in Kerberos. We'll keep it very simple and use it with password authentication. And we will not go over any additional configuration for now because there could be a lot for you. But so as we can see here, we have the RDS free tier. It's available for us for 12 months. And then we'll get 725, basically a full month of RDS free every month for the DB-T2 micro instance, as well as 20 gigabytes free of SSD. So again, this is what we selected, and some space for backups. So we'll create this database. So it took a few minutes, but now my database is created. And here we have some summary. So we know where it is launched, for example, EU Central 1A. We get some information around the endpoint. If you wanted to connect to it, this will be the endpoint and the port to be using. We can have a look at the VPC security group that has been created for my RDS instance and the inbound rules. As we can see, there's an inbound rule on the port, and if I scroll right, on the port 3306 into my instance. So that means that I can use the correct port to connect to my MySQL database instance. Perfect. If we look into monitoring, because this is a managed service, we have some information around the CPU utilization, which is great. So we start really seeing the power of managed services, login events, and so on, configuration, backups, and tags. So as we can see, having a database in the cloud is really helpful when it's managed because, well, we have all the nice monitoring, configuration, settings, and so on associated with it. So this is a huge advantage. Other things you can do is that you can take a snapshot of your database, and this snapshot would allow you, for example, to restore the database into another one. So let's do it demo snapshots, and we'll take this snapshot. So we can't do it because my database is still in a backup stage. So what I'm going to do is wait for it to not be backed up, but to be available. Okay, so my database is now available. So let's go back to actions, take snapshots. And here's my snapshot name, take the snapshot. Now my snapshot is being created. And with it, I have a few options. So I can click on it and I can do a few things. So let's wait for it to be created. Right now it's in the creating status. So my snapshot is now available. And what I can do is do action, restore snapshots. And this would allow me to create a new database out of this snapshot. And the reason why I would do so is that, for example, you wanted to create a bigger database or create a copy of the database and so on, or create a different settings for your database. Then restoring a snapshot would be the way to do it. So I'm going to cancel this. Other things you can do with your snapshot is to copy it. So you can copy it to a different region. And this would be extremely helpful if you wanted to restore the database into another region of AWS, for example, for disaster recovery. So yet another very handy feature. Another thing you can do is share this snapshot. And sharing the snapshot allows you to share with other accounts so that they can restore their database directly from your snapshots. So again, another very handy features. So that's it for RDS, just as a quick overview. So again, we've created a database and we've created a snapshot out of it and we saw different options. So you can see managed services really have a good impact on how you use the cloud, and they really speed it up for you to make sure that you don't manage too much infrastructure. So just to finish this hands-on, let's delete this snapshots. And then we're also going to delete this database by doing action, delete, and then you don't want to create a final snapshot. You do not want to retain automated backups, and you acknowledge that everything will be deleted. Then you type delete me and you're good to go. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So when you deploy RDS databases, you need to understand there are multiple architectural choices you need to make, that you can make actually. So the first is to use RDS read replicas. So let's take the example of your application that reads from your main RDS database. But say that now you need to scale the read workload, so you have more and more applications that need to read more and more data from RDS. The way you can do it is by creating read replicas. So that means that there's going to be some copies, some replicas of your RDS database that are going to be created. And this is going to allow your applications to read from this read replica also. And therefore, you're distributing the reads to many different RDS databases. So you can create up to 15 read replicas. And so as you can see in this example, I have 2 read replicas on top of my main RDS database, and my applications can read from all of them. Now, when it comes to writing data is only done to the main database. So your applications still have to write to the only one central RDS database, okay? So read replicas are used to scale reads. Now we have multi-AZ. And so this is helpful when you have to have failover in case of an AZ outage. So in case an availability zone that crashes, and this gives you high availability. So in this example, your applications still read and write from the same main RDS database, okay? But we are going to set up a replication cross AZ, so in another different availability zone. And this is going to be a failover database. And this is why it's called multi-AZ, because it's in a different AZ. Now, in case the main RDS database crashes for whatever reason, because maybe there's an issue with it, or maybe because the AZ is having problems, then RDS will trigger a failover, and then your application will failover to the failover database in a different AZ. So in this case, data is only read and written to the main database. The failover DB is passive. It's not accessible until there is an issue with the main database. And you can only have one other availability zone as a failover AZ. The last kind of deployment you can do is called multi-region. So this is for read replicas, but this time, instead of being in the same region, they are across different regions. So let's take an example. We have EUS1 for RDS database, and we're going to create a read replica in US East 2. And so applications in US East 2 can read locally from this read replica. But anytime these applications need to write data, the writes need to happen cross region, and so they need to write the data to EUS1. Same if you were to have also another region in AP Southeast 2, so in Australia, you would have the same concept. So why would you want a multi-region type of deployment? Well, number one, because you want to set up a disaster recovery strategy in case of a region issue. So if EUS1 is having a regional issue, then you have a backup in either US East 2 or AP Southeast 2, and this is why it's a disaster recovery strategy. And also, as you can see, our applications that are in different regions get better performance because they read from a local database, so they have less latency. But finally, when you do this, you need to understand that because you are replicating data across regions, then there is going to be a replication cost associated with the network transfers of data between regions. So that's it for RDS deployments. The scenarios that will be proposed to you at the exam will make it clear what deployment you should choose. So I hope you liked it, and I will see you in the next lecture. So now let's talk about a second type of database you will see on AWS, which is Amazon Elasticache. So the same way you use RDS to get managed relational databases, you're going to get Elasticache to get a managed Redis or Memcached database. These caches are going to be in-memory databases with high performance, low latency. So anytime in the exam you see something that says that you need an in-memory database, you have to think directly Elasticache. Now, Elasticache will be helpful to reduce load off of databases that have read-intensive workloads. The idea is that if we have an RDS database and we're doing a lot of query on it and they're the same queries all the time, we put a bit of pressure onto that RDS database. Instead, what we could be doing is to use a cache to reduce the pressure off of the database by making sure the queries are directly going onto my in-memory database through Elasticache. And because this is a managed database, then AWS will take care of all the operating system maintenance and patching, the optimizations, the setup, the configuration, the monitoring, failure recovery, and backups. So we don't need to know a lot about caches in this exam, but we need to know it's an in-memory database. And the solution architecture around using a cache looks like this. So your Elastic Load Balancer will go to your EC2 instances, possibly in an ASG. They will be reading and writing data from your Amazon RDS database, which is slow. And then, if possible, they will be caching some values into an Amazon Elasticache database. And this will be very fast because it's in memory. And so with Elasticache, there will be pressure taken off the main RDS database and put it onto the Elasticache database. And that's the whole idea behind the cache. You want to save the queries somewhere else so that they're very readily available, easily accessible, and they can relieve, again, pressure from the main database. So that's it. That's all you need to know going to the exam, and I will see you in the next lecture. So now let's talk about DynamoDB. DynamoDB is a fully managed, highly available database with replication across 3 availability zones. It is part of the NoSQL database family, so it's not a relational database. DynamoDB is one of the flagship products of AWS. It scales to massive workload, and it's a distributed serverless database. That means that we don't provision any servers. With RDS or with Elasticache, we need to provision a instance type, but with DynamoDB, we don't, so it's called a serverless database, but there are still servers in the backend, we just don't see them. So DynamoDB is great because it scales to millions of requests per second, trillions of rows, and hundreds of terabytes of storage. It has fast and consistent performance, and so anytime you need a single-digit millisecond latency with low latency retrieval, DynamoDB is the database for you. So you would be looking for keywords in your exam, such as serverless and low latency, for example, single-digit millisecond latency. It is integrated with the IAM for security, authorization, and administration, has low cost and auto-scaling capabilities, and finally, a standard and infrequent access IA table class based on how you want to classify your data for cost saving. So the question you may have is, what type of data goes into DynamoDB? Well, it's a key value database, and the data looks like this. You have a primary key, which is made of 1 or 2 columns, a partition key and a sort key, and then attributes on the right-hand side where you can define your own columns for your data. Finally, all the items are going to be row by row, and this is how a DynamoDB table works. Very, very simple, but again, remember, it's a NoSQL database. It has low latency retrieval of data, and you also get access to a serverless database. Then we have DynamoDB Accelerator, also called DAX in the exam. Both can be used. So it is a fully managed in-memory cache for DynamoDB. So this is a cache that's specific for DynamoDB, so it's not like Elasticache. So for example, say your application wants to access DynamoDB tables in DynamoDB. For this, if you want to cache the most frequently read objects, then you would use DAX or DynamoDB Accelerator as a cache in between. And DAX is made just for DynamoDB, okay? So you would not use Elasticache in this case. even though you could, you would use DAX because it's already really, really well integrated with DynamoDB. So this is going to give you a 10x performance improvement. So instead of single-digit millisecond latency to read records, you will have microseconds latency when accessing your DynamoDB tables. It's going to be fully secure, highly scalable, and highly available. And the difference with Elastic Cache, again, is that DAX is only used and is fully integrated with DynamoDB, whereas Elastic Cache can be used for other types of databases to provide caching capabilities. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. Okay, so let's go ahead and practice DynamoDB a little bit. So I'm going to create a table, and I'll call this one demo table. Now in DynamoDB, what you need to do is to specify a partition key. So we'll specify user ID, and sort keys are definitely out of scope for the exam, so let's just consider just the partition key. Okay, so now for the settings in DynamoDB, again, I'm going to leave it as a default settings. You don't need to know the details of how it works. And then you scroll down and you click on Create Table. So our table is now creating. And what I want you to notice is that we are creating a table without creating a database. So the database already exists. It's serverless. We don't need to provision servers. We just need to say, hey, look, I want this table. Please create it for me. And I don't care how it's being run. And that's the whole power of DynamoDB. That's the whole power of serverless services. So now that the table is ready, we can click on View Items and practice a little bit inserting some data into this table. So currently, 0 items are returned because I haven't created anything, but we can create an item in DynamoDB. And for user ID, I can say 1234. So that would be my user ID. We can have a first name to be equal to Stéphane, and we can have a last name to be equal to Marek. And then finally, we could have a number. So I can see a lot of different types we can have. But a number, and could be my favorite number, and it's 42. And click on Create Item. And here we go. My item was written into DynamoDB. So this is super easy. Yet again, I did not have to specify any database, just my table, write some item, and so on. And we didn't have to specify the schema. It just got automatically inferred. Now we have 4 attributes or columns. Now if I can create a second item, so 4, 5, 6, 7, 8, and then add a new string. So for example, first name, and here we're going to have Alice, and click on Create Item. So as we can see in this example, I didn't specify a favorite number or last name for Alice. I just specified first name Alice, and it was still accepted by DynamoDB. So it's a very flexible type of database. It's a very flexible way to insert data. And this whole set of features and particularities make DynamoDB really, really good. But the difference between DynamoDB and, say, RDS is that DynamoDB will have all the data living within one single table, and there's no way to join it with another table. So it's not a relational database. That's why DynamoDB is a non-SQL database, so not only SQL database, so no SQL. And the idea here is that, yes, we cannot link this table to another table, so we need to make sure that all the relevant data is well formatted within our main DynamoDB table. So it changes a little bit how you see database designs and so on. But that's it for DynamoDB. A very quick hands-on to show you an overview. But with DynamoDB, it's a lot more to learn. And this is the focus of the Certified Developer exam, not the Cloud Practitioner exam. So for this example, this is enough. And when you're done and ready, you can just delete the table. You can delete all the CloudWatch alarms associated with it and just type delete in this box, and you'll be good to go. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. Okay, so now let's talk about DynamoDB global tables. So this is one feature you need to know about for DynamoDB. It's a way for you to make a DynamoDB table accessible with low latency, and this is the key, in multiple regions. So let's take an example. We have a DynamoDB table in US East 1, and we'll set up as a global table. So at the basics, of course, our users can do read and write to this DynamoDB table in Northern Virginia, US East 1. But it is possible for us to set up some replication for this global table. So we can create a global table in Paris US 3, and we'll say they're the same. So there's two-way replication between these tables. That means that the same data is in US East 1 and in EU West 3. But users, that are close to the Paris region can access this global table with low latency in Paris. So this is true for 1, 2, 10 regions if you wanted to, okay? A global table is truly global, and users can read and write to the table in any specific region. There will just be replication between these two. So the fact that there is read-write access to any region of AWS on this global table makes it an active replication, because you can actively write to any region and it will actively be replicated into other regions. Okay? So that's it. All you need to know for the exam. I will see you in the next lecture. Okay, next type of database we have is Redshift. Redshift is a database that is based on PostgreSQL, but it's not used for OLTP. OLTP stands for Online Transaction Processing. That is what RDS was good for. Instead, Redshift is OLAP, or Online Analytical Processing, which is used to do analytics and data warehousing. So anytime in the exam you're saying a database needs to be a warehouse and to do analytics on it, then Redshift is going to be your answer. With Redshift, you don't load the data continuously. You load it, for example, every hour. And the idea with Redshift is that it's really, really good at analyzing data and making some computations. So it boasts 10x better performance than other data warehouses and scales to petabytes of data. The data is stored in columns, so it's called a columnar storage of data instead of a row-based. So anytime you see columnar, again, think Redshift. And it has something called the Massively Parallel Query Execution, MPP, engine to do these computations very, very quickly. It's pay-as-you-go based on the instances you have provisioned, and it has a SQL interface to perform the queries. It's also finally integrated with BI, so business intelligence tools, such as QuickSight or Tableau, if you wanted to create dashboards on top of your data in your data warehouse. So that's it, just a high-level overview, but a data warehouse is used to do some computation on your data sets and do some analytics and possibly build some kind of visualizations through dashboards on it. And so for that use case, Redshift would be perfect. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. Another type of database we have on AWS is Amazon EMR. And EMR stands for Elastic Map Reduce. So EMR is actually not really a database. It's to create what's called a Hadoop cluster when you want to do big data on AWS. And a Hadoop cluster is used to analyze and process vast amount of data. So Hadoop is an open source technology, and they allow multiple servers that work in a cluster to analyze the data together. And so when you're using EMR, you can create a cluster made of hundreds of EC2 instances that will be collaborating together to analyze your data. So part of the Hadoop ecosystem, the big data ecosystem, you will see projects named such as Apache Spark, HBase, Presto, and Flink, and all these things will be working on top of your Hadoop cluster. So what is EMR then? Well, EMR takes care of provisioning all these EC2 instances and configuring them so that they work together and can analyze together data from a big data perspective. Finally, it has auto-scaling and it is integrated with Spot instances, and the use cases for EMR would be data processing, machine learning, web indexing, or big data in general. So from an exam perspective, anytime you see Hadoop cluster, think no more, it's going to be Amazon EMR. That's it. I hope that was helpful, and I will see you in the next lecture. So now let's talk about Amazon Athena. Amazon Athena is a serverless query service to perform analytics against your objects stored in Amazon S3. So the idea is that you would use the SQL query language to query these files, but you don't need to load them. They just need to be in S3, and Athena will do the rest. So these files can be formatted in different ways, such as CSV, JSON, ORC, Avro, and Parquet. And the Athena is built on the Presto engine, if you must know. Now, how does that work? So users will load data into Amazon S3, and then Amazon Athena will be used to query and analyze the data. Very, very simple. And then, if you wanted to, you could have some reporting on top of Athena, such as using Amazon QuickSight. Now, the pricing for Athena is around $5 per terabyte of data scanned. And if you use compressed or data stored in a columnar fashion, then you're going to have cost savings because there is less scan of the data being made. So the use cases of Athena are multiple, but anytime you see business intelligence, analytics or reporting, or to analyze flow logs in VPC or ELB logs or CloudTrail logs or CloudFront logs, all these kind of logs in AWS, then Athena is going to be a really, really good option. So from an exam perspective, whenever you see serverless, analyze data in S3, use SQL, then think Amazon Athena. That's it. I hope you liked it, and I will see you in the next lecture. Now let's talk about Amazon QuickSight. So it's a serverless machine learning powered business intelligence service to create interactive dashboards. So behind this very complicated tagline, all you have to remember is that Amazon QuickSight allows you to create dashboards on your databases so you can visually represent your data and show your business users the insights they're looking for, okay? So QuickSight allows you to create all these kind of cool graphs, charts, and so on. So it's fast, it's automatically scalable, it's embeddable, and there's per session pricing, so you don't have to provision any servers. The use cases are business analytics, building visualizations, performing ad hoc analysis, get business insights using data, And in terms of integrations, there are so many, but for example, QuickSight can run on top of your RDS database. It can run on top of Aurora, Athena, Redshift, Amazon S3, and so on. So QuickSight is your go-to tool for BI in AWS. That's it. I will see you in the next lecture. Now let's talk about DocumentDB. So the same way we had Aurora as the way for AWS to implement a sort of big cloud native version of PostgreSQL and MySQL, we have DocumentDB, which is an Aurora version for MongoDB. So MongoDB, if you don't know, that's the logo on the top right corner of your screen. It is another NoSQL database, and you need to remember this for the exam. So DocumentDB is a NoSQL database, and it's based on top of the MongoDB technology. So it's compatible with MongoDB. So MongoDB is used to store, query, and index JSON data. And you have the same similar deployment concept as Aurora with DocumentDB. So that means it's a fully managed database. It's highly available. Data is replicated across 3 availability zones. And the storage will grow automatically in increments of 10 gigabytes up to 64 terabytes of storage, all of this, okay? And DocumentDB has been engineered so it can scale to workloads with millions of requests per second. So at the exam, if you see anything related to MongoDB, think DocumentDB. Or if you see anything related to NoSQL databases, think DocumentDB and also DynamoDB. That's it for this lecture. I hope you liked it, and I will see you in the next lecture. Now let's talk about Amazon Neptune. Neptune is a fully managed graph database. So an example of what a graph dataset would be, for example, something we all know, which is a social network. So if we look at a social network, people are friends, they like, they connect, they read, they comment, and so on. So users have friends, posts will have comments, comments have likes from users shares and like posts. And so all these things are interconnected. And so they create a graph. And so this is why Neptune is a great choice of database when it comes to graph datasets. So Neptune has replication across 3 AZ, up to 15 read replicas. It's used to build and run applications that are going to be with highly connected datasets, so like a social network. And because Neptune is optimized to run queries that are complex and hard on top of these graph datasets. You can store up to billions of relations on the database and query the graph with milliseconds latency. It's highly available with replication across multiple availability zones. And it's also great for storing knowledge graphs. For example, the Wikipedia database is a knowledge graph because all the Wikipedia articles are interconnected with each other. Fraud detection, recommendations engine, and social networking. So coming from an exam perspective, anytime you see anything related to graph databases, think no more than Neptune. That's it. I hope you liked it, and I will see you in the next lecture. Now let's talk about Amazon QLDB, which stands for Quantum Ledger Database. So what is it? A ledger is a book recording financial transactions. And so QLDB is going to be just to have a ledger of financial transactions. It's a fully managed database. It's serverless, highly available, and has replication of data across 3 availability zones. And it's used to review history of all the changes made to your application data over time. That's why it's called a ledger. So it's an immutable system as well. That means that once you write something to the database, it cannot be removed or modified. And there's also a way to have a cryptographic signature to make sure that indeed nothing has been removed. So how does it work? Well, there is behind the scenes a journal. And so a journal has a sequence of modifications. And so anytime a modification is made, there is a cryptographic hash that is computed, which guarantees that nothing has been deleted or modified. And so this can be verified by anyone using the database. So this is extremely helpful for financial transactions because you want to make sure that obviously no financial transaction is disappearing from your database, which makes QLDB a great ledger database in the cloud. So you get 2 to 3 times better performance than common ledger blockchain frameworks. And also you can manipulate data using SQL. Now, as you'll see in the next lecture, there's also another database technology called Amazon Managed Blockchain. But the difference between QLDB and Managed Blockchain is that with QLDB, there is no concept of decentralization. That means that there's just a central database owned by Amazon that allows you to write this journal, okay? And this is in line with many financial regulation rules. So the difference between QLDB and Managed Blockchain is that QLDB has a central authority component and it's a ledger, whereas Managed Blockchain is going to have a decentralization component as well, okay? So that's it. Anytime you see financial transactions and ledger, think QLDB. I will see you in the next lecture. Now let's talk about Amazon Managed Blockchain. So what is blockchain? It makes it possible to build applications where multiple parties can execute transactions without the need for a trusted central authority. So there's a decentralization aspect to a blockchain. So Managed Blockchain by Amazon is a service to join public blockchain networks or create your own scalable private blockchain network within AWS. And it's compatible with two blockchains so far, the framework Hyperledger Fabric and the framework Ethereum. So from an exam perspective, if you see anything related to blockchains or Hyperledger Fabric or Ethereum, you have to think Amazon Managed Blockchain, which is also a decentralized blockchain, okay? So make sure you remember that, and that's it. All you need to know for the exam, you'll need to be a blockchain expert. So that's it. I hope you liked it, and I will see you in the next lecture. Okay, now let's talk about AWS Glue. So Glue is a managed extract, transform, and load service, or ETL. And from an exam perspective, that's all you need to know. But let's go a little bit deeper dive to understand how that works. So what is ETL? Well, ETL is very helpful when you have some data sets, but they're not exactly in the right form or the right format that you need to do your analytics on them. And so the idea is that you would use an ETL service to prepare and transform that data. So Glue does that, but traditionally you use servers to do it, but with Glue, it's a fully serverless service. So you just worry about the actual data transformation and Glue does the rest. So in a diagram, for example, Glue ETL sits in the middle and say we wanted to extract data from both an S3 bucket and an Amazon RDS database. So for this, we would use Glue to extract the data from both these sources. And then once the data is extracted, it is in a Glue service and we would write a script to do a transform part. So here, Glue would help us transform the data. And then once it's transformed, we need to actually analyze it so we can load that data into, for example, an Amazon Redshift database where we can do our analytics the right way. And so Glue sits here, okay? It's a very powerful tool because you can do any kind of extraction, transformation, and then you can load it into many different places. So that's for Glue ETL. And then there's another service called Glue Data Catalog, which I think is not at the exam, but I will still mention it to you because it's important to know it as part of the Glue family. So the Glue Data Catalog, as the name indicates, is a catalog of your data sets in your AWS infrastructure. And so this Glue Data Catalog will have a reference of everything, the column names, the field types, etc., etc. And this can be used by services such as Athena, Redshift, and EMR to discover the data sets and build the proper schemas for them. Okay, so that's it. I hope you liked this lecture and I will see you in the next lecture. So we have seen in this section so many different database technologies, and the question is, how do you migrate data from one database to another? For this, we can use DMS, which is promptly named the Database Migration Service. So we have a source database, and we want to extract the data. So we'll run an EC2 instance that will be running the DMS software. We'll extract the data from the source database, and then DMS will insert the data back into a target database that will be somewhere else. So with DMS, we get a quick and secure database migration into AWS that's going to be resilient and self-healing. And the cherry on the cake, the source database remains available during the migration, so we don't have to take it down. It supports many kinds of migrations. So one is called an homogeneous migration, where you have Oracle to Oracle, for example. So it's the same database technology for the source database and the target database. Or it supports heterogeneous migrations when the source database technology and the target are different. For example, a Microsoft SQL Server to Aurora. And in that case, DMS is smart enough to know how to convert data from the source into the target. So anytime in the exam you see a migration of a database, DMS is going to be the answer for it. I hope that was helpful, and I will see you in the next lecture. So let's summarize everything we know about databases and analytics in AWS. And you just need to know what database corresponds to what use case going into the exam. So if you have a relational database and you have OLTP, so online transaction processing, you have to think RDS and Aurora. And both these databases support the SQL language, SQL language, to query your data. You also need to know for RDS the difference between a multi-AZ deployment, replicas, and multi-regions, as well as their use cases. If you need to find an in-memory database or in-memory cache, think Elasticache. If you're looking for a key value database, think DynamoDB, which is a serverless database. And if you need caching technology for DynamoDB, then use the DAX technology, which is a cache made specifically for DynamoDB. If you're looking for a data warehousing or OLAP, online analytical processing, then you need to look at Redshift, which is a warehousing technology, and you can also use the SQL language to query data on Redshift. If you're trying to build a Hadoop cluster to do big data analysis, use the EMR service. If you want to query data on Amazon S3 in a serverless fashion with the SQL language, then use Athena. QuickSight is a way to create dashboards, so visually interactives, visuals and so on, that can be interactive as well on your data in a serverless fashion. Then you would use Amazon QuickSight, also used for business intelligence. DocumentDB is what I call the Aurora of MongoDB. So anytime you see MongoDB, think DocumentDB, which is also using the JSON type of data sets. And this is a NoSQL database. So this is another NoSQL database on top of DynamoDB. Then we have Amazon QLDB, which is a financial transaction ledger. Anytime you would see financial transaction, immutable journal, something that is cryptographically verifiable, think Amazon QLDB. And this is a central database, which is opposed to a decentralized database, which is Amazon Managed Blockchain, in which case we can have Managed Hyperledger Fabric and Ethereum blockchains on AWS. Finally, if you want to have a managed extract, transform, and load tool, so ETL, we can use Glue, which also has a data catalog service to discover data sets into your various databases in AWS. And finally, if you need to move data between databases, then you would use the DMS service for database migration service. Oh, so don't forget, there is Neptune if you have a graph database. That's it. I hope you liked it, and I will see you in the next lecture.